Today we will solve the Laplace Transform PYQ from section B, question 6 to 10. So this is the first question that we are solving. Solve any 5 each for 2 marks, as for 10 marks. A, B, C, D. These 4 questions are on Laplace Transform that we are solving today. So I have just written all those questions here. Basically, these types of questions are completely based on the theorems of Laplace Transform. So let's start with the first question. Question 6a. First question is L of f of t minus a, u of t minus a is nothing but what? Now here we are applying the second shifting theorem. We are directly applying the theorem that we have seen in Laplace transform to get the answer of these types of question. So by second shifting theorem, the value of Laplace of f of t minus a, u of t minus a is nothing but e raised to minus as f of s, where f of s is L of f of t and u of t minus a is unit step function. Then next question is B. If f of L of f of t is f of s, then L of t raised to an f of t is nothing but what? Now here we are applying the multiplication by t raised to n property. So multiplication by t raised to n property, L of t raised to n f of t is minus 1 raised to n d raised to n ds raised to n f of s. Okay, this is the final value of this question. Third question is if L inverse of f of s is f of t, then L inverse of integration s to infinity f of s ds is what? Now by division by t property, we have L of f of t by t is integration s to infinity f of s ds. So if I am applying the inverse Laplace on both sides, what will get? L inverse of integration, here I am applying inverse Laplace, so it implies L inverse of integration s to infinity f of s ds is f of t by t. I'm just applying inverse Laplace transform over this expression to get this value. So final answer is f of t upon t. Last question is L inverse of 1 upon 3s plus 1 square. Now to solve this expression, firstly I am just expressing denominator like this. So 1 upon 3s plus 1 square can be written as 3 into bracket s plus 1 by 3 bracket square. So this must be 1 by 9 s plus 1 by 3 square. Now here I am applying first shifting theorem for inverse Laplace transform. So this must be L inverse of f of s minus a is e raised to at L inverse of f of s. Here, what is the value of a? If you compare s minus a with s plus 1 by 3, the value of a must be minus 1 by 3. Okay. Next to that, L inverse of 1 upon 9 s plus 1 by 3 square is, I'm taking inverse Laplace transform on this expression using shifting theorem. So we have, what is the value we get? 1 upon 9 e raised to value of a is minus 1 by 3. So this become minus t by 3 L inverse of 1 upon s square. Value of f of s is 1 upon s square. Now we have to find out the value of L inverse of 1 upon s square. So to get that value, we use the formula of Laplace of t raised to n. This is the standard formula. It says that it is n factorial s raised to n plus 1. So if I put value of n equals 1 in this expression, what will get? L of t is 1 factorial, that is 1, divided by s square. 1 plus 1, that is 2. So again here applying the inverse Laplace transform, we get value of t is L inverse of 1 upon s square. So it means t is L inverse of 1 upon s square. So if I put that value here, we get 1 upon 9 e raised to minus t by 3 into 3 is the final value. This is the final value of the expression L inverse of 1 upon 3s plus 1 square. Question number 7a. Find Laplace transform of cos at minus cos bt upon t. Ask for 5 marks. This question I have already solved in my previous video. Question 8a. Find Laplace transform of integration 0 to infinity e raised to minus 2t t square sin 3t dt. Ask for 5 marks. This question also I have solved in my previous videos. Go and check it. Now the next question is question number 9a. Express f of t in terms of Heaviside unit step function. Hence find its Laplace transform. F of t cos t. T runs from 0 to pi. Cos 2t t runs from pi to 2 pi and cos 3t t greater than 2 pi. Ask for 5 marks. Let's solve this question. Now, in this question, we apply second shifting theorem. Second shifting theorem says that L of g of t u of t minus a is e raised to minus as L of g of t plus a. This is equation number 1. Now, I am solving this question in 3 different parts. So, first term that I am taking here, for first term, I am writing here the given expression. This is f of f1t, f2t, f3t. Three different functions they have given here. So we are solving this question in 3 different parts. First part for cos t. Then in the second part we are combining these 2 functions. And in the third part we are combining these 2 functions. So in the first part cos t ut for a equals to 0. Now if you observe here, in the first term shifting was at a equals 0, giving u of t minus 0 as u of t, and the value of u of t unit step function is 1 for all positive time t. Okay, hence just we have the value. We are going to find out the value of Laplace of cos t. Now we have the standard formula of Laplace of cos t. What is the value? It is s upon s square plus a square. Value of a is 1, so s square plus 1. This is our equation 2. Now we are solving for the second term. Now we are in the second term, switch happens at a equals to pi. When applying second shifting theorem, to find the Laplace transform, we evaluate function in the region where it is active. So step function u of t minus pi is treated as 1 for all t greater than equals to pi. Okay, so that's why I am writing here value of g of t is cos 2t minus cos t only, because u of t minus pi is 1. So now as the value of t shifts from t to t plus pi, so we can write here g of t plus pi is cos of 2 of t plus pi minus cos of t plus pi. So simplify further, so you will get cos of 2t plus 2 pi minus cos of t plus 5. Now here we are applying trigonometric identity of cos function. Cos of theta plus 2 pi. What is the value of cos of theta plus 2 pi? It is simply cos theta. And value of cos of theta plus pi, it is minus of cos theta. Minus of cos theta. So if you apply that formulas here, cos of theta plus 2 pi, it is simply cos 2t. Similarly, cos of t plus pi, cos of theta plus pi is minus cos theta. So cos of t plus pi is simply minus cos t. Minus of minus become plus cos t. Now next to that we are applying Laplace transform here. So Laplace of g of t plus pi. What is the value we are getting here? Laplace of, this is the value of Laplace of g of t plus pi. Laplace of cos 2t is s upon s square plus 4. S upon s square plus 1 is the value of cos t. From 1 we have the value of we are going to find out the value of L of g of t u of t minus a. So here L of g of t plus pi is nothing but e raised to minus s. Now value of a is pi, so e raised to minus pi s, and the value of L of g plus L of g of t plus a. So it is s upon s square plus 4 plus s upon s square plus 1. Now this is your equation number 3. Similarly, you are solving the third term. So for third term, you are taking the function cos 3t and cos 2t. So hence here the value of a is 2 pi, and the value of h of t you are taking it as cos 3t minus cos 2t. Now in the third term, which happens at a is equals to 2 pi. So you can say that the value of u of t minus 2 pi is again 1. So u of t minus 2 pi is 1 for all t greater than equals to 2 pi. Okay, so here t shifts from t to t plus 2 pi. Hence we can write value of h of t plus 2 pi is cos of 3t plus 2 pi minus cos of 2t plus 2 pi. So this is nothing but what? Cos of 3t plus 6 pi minus cos of 2t plus 4 pi. Now here we are applying the formula of cos 2 theta plus 2n pi is nothing but cos theta, because adding or multiplying of 2 pi doesn't change the cosine value. Hence we can easily say that the value of cos 3t plus 6 pi is nothing but cos 3t. Similarly, cos 2t plus 4 pi is cos 2t, because you can rewrite it as 6 pi as 2n pi, 2 into 3 into pi. Similarly, here 4 pi is 2 into 2 into pi. So hence the value of h of t plus 2 pi is nothing but cos 3t minus cos 2t. Now taking Laplace, so Laplace of h of t plus 2 pi is Laplace of cos 3t. So this is s upon s square plus 3 square, that is 9, minus s upon s square plus 2 square, that is 4. So hence from equation 1 you can say that the final value of Laplace is e raised to minus as. Now value of a is 2 pi, so e raised to minus 2 pi s, and the bracket s upon s square plus 9 minus s upon s square plus 4. This is your equation number 4. So combining equation 2, 3 and 4, you are getting final value of f of s as s upon s square plus 1 plus e raised to minus pi s upon s square plus 4 plus s upon s square plus 1, and then last value plus e raised to minus 2 pi s upon s square plus 9 minus s upon s square plus 4. This is the final answer. Now the next question is, what if they ask the same question for sign values, because they already asked this type of question in previous year exam papers. Now it's your turn. Here is the another PYQ based on the same concept. Try solving it. This is the question number 10. Express the following function in the terms of Heaviside unit step function. Find a Laplace transform for f of t, sin 2t and sin 3t. Pause the video and give it a try. I have solved this question in the next video. Click the link in the comment section to get the solution along with the question paper.